Acute myeloid leukemia, or AML, is a clonal malignant disorder. Originating in the bone marrow, hematopoietic stem cells become leukemic after undergoing genetic and molecular changes. Leukemic stem cells self-renew and produce blast cells, which accumulate at the cost of normal hematopoiesis. Blast cells create an environment that promotes their own survival. They secrete cytokines, such as TNF-alpha and IL-1 beta, activating receptors on the vascular endothelial cell surface and inducing increased expression of the adhesion protein E-selectin. E-selectins bind to leukemic cells via receptors containing the carbohydrate sialyl Lewis X, such as CD162, sequestering the cells to the vasculature where they effectively hide from cytotoxic therapies. By binding to E-selectins, leukemic cells gain pro-survival properties as mediated through the NF-kappa B protein, which is constitutively expressed in AML blasts. Activation of this pathway confers protective mechanisms onto the leukemic cell, including the upregulation of proteins involved in apoptotic resistance, such as BCL2. Leukemic cell binding to E-selectins thereby helps them to survive, making AML difficult to treat. Uproleselan is a glycomimetic compound that mimics sialyl Lewis X. It binds to E-selectins on the vascular endothelium with high affinity and thereby inhibits or blocks leukemic blast cells from binding. Without this protection, these cells become vulnerable to cytotoxic therapies, including BCL2 inhibitors, FLT3 tyrosine kinase inhibitors, and hypomethylating agents, resulting in their death. Glycomimetics uproleselan successfully disrupts the chemoprotective mechanisms provided by E-selectin and NF-kappa B, sensitizing leukemic cells to many therapies. This helps to restore a healthy bone marrow and improve outcomes.